and see two things how it works. Well, you see this expression, very simple rational expression. There's not much to it, but there's a monomial on top, a monomial on the bottom. You got 6/9, and you got x to the third y squared, x squared y. Well, here's what I've done for you. I've taken the top part and the bottom part and wrote it out in expanded form. So I've taken this particular 6 and wrote it 2 times 3. X to the third is x times x times x. Y squared is just y times y. Same, likewise. The 9 I did 3 times 3. This is xx and this is y. Notice they're all multiplied. It's multiplication, 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 multiplication. Ha! Thought I was stuttered, but I didn't. All those are multiplied. So that means if I have something on top that's exactly the same as on the bottom, since they're factors, I can cross them off. Which, by the way, is why it says match them up and cross them off. It's exactly what I always tell people. If you can match them up on the top, as long as they're factors, you can cross them off. Check this out. That means I can take the 3 and the 3, match them up, cross them off. Match them up, the x's. I got one pair of x's there. I got a second pair of x's there. I got a pair of y's. Sweet. So I've matched the y on the top and y on the bottom, those x's and those 3's. And as you see, what I'm left with, if I erase those all I'm really left with is just the 2 and the x. Oh, sorry, and the y. So I get 2xy on the top, that's in the numerator. And this 3, even though it's the only thing in the denominator, ladies and gentlemen, it doesn't come to the top, it doesn't disappear, it stays in the downstairs basement. It stays in the denominator. So that's why I get 3. So this will be my simplified version of that guy right there. You got me? Sweet! Over here, example number 2, what I've done for you is 12x to the third, y to the fourth, 2xy squared. I've written that out like this. 12 is the same as 2 times 2 times 3. X to the third is all these written out. Y's are all written out. 10 is the same as 2 to the fifth. X, y squared. Now, here's why I've done that. Because notice they're all being multiplied. So if they're all being multiplied, then I can take and cross them off after I match them up. So I match them up. Here's a 2 and a 2. Sweet. Later. I got x and x. They're gone. I got y, 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 y. So I can match them up, cross them off, and then just clean it up. I should probably put that as the third thing. Match them up, cross them off, and clean them up. So you can do this. 2 times 3 is a 6. X times x is just x squared. And y times y is y squared. And then the only thing I have left in the denominator is just a 5. And there's your answer. So here you go. So there's an example number 2. Let's keep rolling. Okay. So if you look at this one, directions say simplify if at all possible. Here's your example over here in the little box. 8x squared times the quantity of x plus 1. Well, now remember, this is really a multiplication here, as is this. So that's kind of important to be able to see. It's 8 times x squared times x plus 1. And down here you have 2x squared plus 2x. Well, I will tell you the very first thing that you must do in all these questions, even when you're simplifying, is to see, as we did before when we factored trinomials, you have to see if there is a, bam, GCF. If there's a GCF in the top, you must then factor out the GCF. If there's a GCF in the bottom, then you got to factor out the GCF. And in fact, I see it just as you do, that there's a GCF right here. So that GCF in these two terms is a 2x. So I factor that 2x out and I get 2x plus the quantity, or sorry, times the quantity of x plus 1. And again, it's important to note that this is a multiplication, as is this, likewise up here. So they're actually all being multiplied. 8 times x squared times this thing, and then 2 times x times this thing. So whenever I do that, take a look what I've done down here. I come down to this step, and I just kind of write the 8 as a 2 times 4, x squared is x times x plus 1 is just x plus 1, and then this 2x and the x plus 1, I just wrote them out. So why did I do that? Because if you notice, now you can really see everything here is being multiplied. Everything here is being multiplied. It just so happens that this funky looking thing happens to be a quantity in parentheses, but it's still its own little factor. That's why it's grouped together. So that means I can match them up and cross them off. So this 2 is gone. This x is gone. Up here, oh, I don't have another x. Oh, I do have an x here, but be careful. We're grouping things together. So you got to make sure you compare factor grouped things. So x plus 1 is grouped together. X plus 1 is grouped together. So since it's a factor, because we're multiply, this whole thing crosses off with this whole thing. Bam. So now all you're left with is just a 4 and an x on the top, and actually nothing on the bottom. So that's why your answer is just 4x. Sweet. Let's go to another example. Okay. So all this being said, we're getting to culminating to something pretty big. So if you look at this, now here's what I've done. I've kind of paralleled two examples for you. A very simple one down here to one that has a lot of factors in it, a lot of binomials. So you see A times B times C written out like this. A times C times D written out like this. Why did I do that? Because notice, if it's all being multiplied, whatever A is, it can be a number or it could be an actual binomial or it could be a trinomial. But as long as it's something, number, variable, expression, whatever, that means I can say if it's the same on top and it's the same on the bottom, it's crossed off. C on top, C on the bottom, it's crossed off. So I'm left with B over D, and there's my answer. It parallels to what you see down here. Even though it looks uglier, notice this. It's the quantity of x plus 3 times the quantity of x minus 4 times x plus 6. It's the same as A times B times C. And down here, it's the same as A times C, notice C, 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 times D. It's the same thing as what you just see up here. So it's the same concept. Since I'm multiplying these goofy looking things, they're just factors. And I can match them up and cross them off. X plus 3, X plus 3, just like I did A and A. C and C, music factory, I can take the X plus 6 and the X plus 6 which are the same and cross them off. I match them up and cross them off. So I'm just left with on the top x minus 4, bam, and I'm left with x plus 4, bam. And this is my final answer. Now some of you might be thinking, wait a minute, there's an x on top and x on the bottom, why can't I cross them off? Because it's not a factor. There's nothing in here that says multiplication, there's a subtraction, and there's an addition. So there's nothing else you can do. That is simplified as much as possible. So there you go. Now let me give you one example here, a little bit more in depth. I'm going to put it all together. Okay. Putting all this stuff together, here's your example. And this is really how they're going to be presented to you in this section, and the chapter tests and quizzes and even PSSAs and SATs. It's going to tell you this question here, that rational expression. And it's going to say, simplify it if possible. Well, first thing you got to look for is, can I take out a GCF? Is there a GCF in this top one? Nope. Is there a GCF in the bottom that I can take out? Nope. So you don't have to worry with it. Sometimes you do have to do it, sometimes you don't. And then you have to go factor. Well, let's see if I can take this trinomial and factor it into two things. Well, use your Xbox method, and you'll see when you do the Xbox method, again, this goes -2, that's the A times C, and then the B goes right there. What can I put in here that actually makes it work, where I multiply to give me -2, and I add to give me +1? Well, that would be a 2 and a -1. So I use those, and I put them in here, 2 and -1. So there is my factored form of that trinomial. Sweet. Now I go to the bottom. Oh look, is it the difference of two squares? I don't know. Is it binomial? Yep. Is it subtraction? Yep. Can I take the square root of this? I believe I can. The square root of that is an x. Can I take the square root of 1? I believe I can. That is 1. So it satisfies the difference of two squares, so it factors into a special pattern. X minus 1, x plus 1. Bam. So I factored the top, I factored the bottom. Numerator is factored, denominator is factored. And now, check this out. It's factored, meaning these things are multiplied. It's this thing here times that would give you that. That's what factors are called. So, match them up and cross them off. It's very rare that you're going to have a situation where they won't cross off, especially with what we talk about this year. It can certainly happen. But if you notice, there is something on top that's the same as on the bottom. Now, I'm not talking x and x. I'm talking grouping together. So this factor x minus 1 and this factor x minus 1 are exactly the same. That means I can cross them off. And I can clean it up by saying, since these are gone, all I have left is x plus 2, bam, and x plus 1, bam. And again, that is my final answer. I cannot take the x's and cross them off because there's nothing there that's being multiplied. They're not factors. So you can't do that. So x plus 2 over x plus 1, and we are done. You can see the little symbol now for example number 2. Pause it. I want you to do this example right there. There's your numerator, x squared minus 4x minus 12. The denominator is x squared plus 5x plus 6. Take that thing and simplify it. Good luck. I'll give you another video to show you the answer. Good luck. Bye-bye.